Key point number 5. Once you understand the basics, solving the problems are very, very easy. Key point number 5. Key point number 5 is divisibility rule for k minus 1 for base system k. Divisibility rule for k minus 1 for base system k. For base system k, what is the divisibility rule for k minus 1? Concepts. It's all about concepts, sir. If xyz is in 10, x is there in hundreds place, so 100x plus 10y plus z. 100x plus 10y plus z. So these nothing but 10 power 0. These nothing but 10 power 1. These nothing but 10 square. So what is the divisibility rule for 3 or 9? 9 we got. Sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9. Suppose instead of 10, if I take 5. These 5 power 0, 5 power 1, 5 square. This is 25x plus 5y plus z. These nothing but 24x plus 4y plus x plus y plus z. Now if you observe carefully, x, y, z in base system 5, if this is divisible by 4, 24 is divisible by 4, these also divisible by 4, x plus y plus z should be divisible by 4, x plus y plus z should be divisible by 4. I hope you got the idea, right? Again, for 5, what is the sum of the digits? It should be divided by 4. Suppose if it is base system 7, this is 49x, this is 7y and it is z. These nothing but 48x plus 6y plus x plus y plus z. Again if you observe, this is not, if this is divisible by 6, 48 is divisible by 6, these also divisible by 6. X plus y plus z should be divisible by 6. That means in base system 10, sum of the digits should be divisible by 9. In a base system 5, sum of the digits should be divisible by 4. In a base system 7, sum of the digits should be divisible by 6. I hope this point is extremely clear to you. With this, we will write down in a base system 10, if a number is given 9, what is the divisibility rule? Divisibility rule is nothing but the sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9 for a base system 10 and for the numerical value 9. If it is for 7, if it is for 6, again it is sum of the digits should be divisible by 6. If it is base system 5, if I want what is the divisibility rule of 4, again it is nothing but sum of the digits should be divisible. That means extremely important point, in a base system k, divisibility rule for k minus 1. Divisibility rule for k minus 1 is nothing but sum of the digits should be divisible by k minus 1. Extremely important key point. In any base system k, divisibility rule for k minus 1 is sum of the digits should be divisible by k minus 1. I hope this point is clear. Now next point. Key point number 1, what is the place value? How to represent xyz in terms of the base system? If x is there in tens place, 10x plus y. If xyz there is a 3-digit number, x is there in a 3-digit, 100x plus 10y plus z. Divisibility rule for 2, divisibility rule for 5, divisibility rule for 10, divisibility rule for 2, 2 square, 2 cube, 2 power 4 and so on up to generalization for 2 power k. Divisibility rule for 3 and then for 3 square. Then trying to draw an analogy. What is the divisibility rule for k minus 1 in a base system k? Key point number 5. Please write down. Key point number 5. Key point number 5. Now what is this key point number 5? Divisibility rule for 11. Divisibility rule for 11. There are multiple divisibility rules for 11. One by one we will discuss concept. If XYZ is in base system 10, X is there in hundreds place, Y is there in tens place, Z is the units place. So these nothing but 99X plus 11Y plus X minus Y plus Z plus X minus Y plus Z. I hope this point is clear. 99X plus X is 100X, 11Y minus Y is 10Y. Now if you see carefully, if XYZ base system 10, if this is divisible by 11, if this is divisible by 11, 99 is divisible by 11, which is 9 into 11. These also divisible by 11. These also divisible by 11. X minus Y plus Z should be divisible by 11. X minus Y plus Z, or in other words, it is nothing but the X plus Z minus Y. X plus Z minus Y. What is X plus Z? It is nothing but the sum of the odd places. What is Y? Y is nothing but the even places. That means sum of odd places, minus sum of even places, sum of odd places minus sum of even places should be divisible by 11, or the difference of the odd places and even places sum, it should be 0. I hope the idea it is clear. Sum of odd places minus sum of even places. Either if it is 0, 99 is divisible by 11, 11 is also divisible by 11. So 0 means perfectly the right hand side is divisible by 11, or otherwise this should be divisible by 11. These nothing but X minus Y plus Z. These nothing but X plus Z minus Y. X plus Z is nothing but sum of odd places. Y is nothing but even place. Sum of odd places minus sum of even places. Either it should be divisible by 11 or it should give a difference as 0. I hope this concept is clear. This method 1. Sum of odd places minus sum of even places should be divisible by 11 or 0. Method 2. Another method we will see it. Another method. Method number 2. Method number 2. 11 is nothing but 10 power 1 plus 1. Now, why am I writing like this? Suppose 10 divided by 11, which is nothing but minus 1. 10 square divided by 11. 10 square is 100. 100 is nothing but 99 plus 1 divided by 11. 99 is divisible by 11. Remainder is nothing but 1. That 10 cube divided by 11, which is nothing but remainder of 10 into 10 square divided by 11 minus 1 into 1 minus 1. These nothing but remainder 10 power 4 divided by 11, 10 square whole square. So 10 square by 11 whole square. 1 square is nothing but 1. 1 square is nothing but 1. Now if you observe, remainder 1, 10 square divided by 11, it is 1. 10 cube divided by 11, it is minus 1. Two beautiful conclusions. First I will take an example. Remainder 1, 1, 2, 3, 4 divided by 11. Remainder 1, 1, 2, 3, 4 divided by 11. Method number 1. Sum of the odd places minus sum of the even places. 4 plus 2, 6. 3 plus 1, 4 divided by 11. 6 minus 4 is 2. 2 divided by 11 is 2. Method number 1. Method number 2. This can also be written as 12 into 10 square plus 34 divided by 11. Are you all with me? 10 square divided by 11, 100 divided by 11, 11 nines are 99, remainder 1, 12 plus 34 is 46. 46 divided by 11, 11 fours are 44. What is the remainder? 2. That means take a group of 2 digits, add them. Take a group of 2 digits and add them. This is the another divisibility rule. This is the another divisibility rule for 11. This is the another divisibility rule for 11. Let us start from, write down the logic. Start from unit digit. Start from unit digit. Start from unit digit. Take a group of 2 digits. Take a group of 2 digits and add them. If I take a group of 2 digits and add them, I will get the divisibility rule by 11. I will get the divisibility rule by 11. Start from unit digit. Take a group of 2 digits and add them. Take a group of 2 digits and add them. Suppose, for example, if the question is 1212 divided by 11, what is the first method? Sum of odd places minus sum of even places. 2 plus 2, 4. Even places is nothing but 2. 4 minus 2, it is nothing but 2. This is the first method. Second method, take a group of 2 digits and add them. 12 plus 12, which is nothing but 2 into 12 divided by 11. 11 ones are 11, remainder 2. Take a group of 2 digits and add them. Take a group of 2 digits and add them. Suppose if the question is 23, 23, 23, 23 divided by 11. Instead of taking sum of the odd places and sum of the even places, take a group of 2 digits and add them. 23, 23, 23 added 4 times. So it is 23 into 4 divided by 11. 11 twos are 22, remainder 1, 1 into 4 is 4. I hope the second concept of divisibility rule for 11 is also clear. Start from the unit digit, take a group of 2 digits and alternate and add them add them. This is the divisibility rule for 11 for method number 2. Method number 3. There is also another divisibility rule. Method number 3. Method number 3. Suppose what we discussed, 10 cube divided by 11, which is nothing but minus 1. We wrote it after 10 square by 11. Now if you see, remainder 1, 10 power 6 divided by 11, minus 1 square is nothing but 1. So another concept, this is not only for this number, but also for remainder 1. 10 power 3 divided by 7 is minus 1, because 7 ones are 7, 3 cube. 3 cube is 27, 7 fours are 28, minus 1. Next it is remainder 1. 10 cube divided by 13. 13 ones are 13, minus 3. Minus 3 cube is minus 27. 13 minus 2s are minus 26. Remainder is minus 1. Another beautiful concept. There are some good previous year questions that came from this concept. Divisibility rule for 7, 11 and 13. Divisibility rule for 7, 11 and 13. Extremely important rules, sir. Right? I have discussed in elaborate in the divisibility rule of a prime number concept. Now, I'll just tell you the definition and the usage. What is the concept? Start from unit digit. Start from unit digit. Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. Alternatively add and subtract. This is the divisibility rule for 7, 11 and 13. Alternatively add and subtract to get the divisibility rule for 7, 11 and 13. First question. Suppose if it is 1, 2, 3, 1, 2, 3 divided by 11. 1, 2, 3, 1, 2, 3 divided by 11. What is the divisibility rule? Start from the rightmost, take a group of 3 digits. Alternatively add and subtract. 123 minus 123, it is 0. 0 by 11, it is 0. I hope the idea it is clear. Take a group of 3 digits and add it. Suppose if the logic is 234, 234, 234, 234 divided by 11. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. This minus this 0, this minus this 0. That means very important key point. Any 3-digit number written even number of times is always divisible by 11. 7, 11, 13 in fact, not only 11. Any 3-digit number written even number of times, any 3-digit number written even number of times, any 3-digit number written even number of times is always divisible by 7, 11 and 13. Any 3-digit number written even number of times is always divisible by 7, 11, 30. Extremely important concepts. Only if you know these concepts, you can solve a lot of problems very, very quickly. These again for 7, 11, 13. I have discussed in elaborate for the enrolled students when I was discussing the divisibility rule for a prime number, and I also discussed the divisibility rule of any prime number by using theory of osculation. I hope it is clear. Any 3-digit number written even number of times is always divisible by 7, 11, 13. Now, key point number 6. Key point number 6. In divisibility rule for 11, we discussed take sum of the odd places minus sum of the even places should be divisible by 7, 11, 13. Take a group of 2 digits, add them, that is also the divisibility rule of 11. Take a group of 3 digits, alternatively add and subtract. Alternatively add and subtract. That is the divisibility rule for 7, 11 and 13. Now, let us discuss the divisibility rule for composite number. Divisibility rule for composite numbers. 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 Now see here. Any composite number, right, except the square of a prime number. Except the square of a prime number. Except the square of a prime number. Every other number can be written as product of 2 coprimes. Try to write down it as a product of 2 coprimes. Try to write down it as a product of 2 coprimes. Now, what we will do is, suppose 6 is there. 6 is nothing but 1 into 6, and it is nothing but 2 into 3. 6 writing the number itself is 1 into 6. 2 and 3. 2 numbers are said to be coprimes. 2 numbers are said to be coprimes if their HCF is 1. If A and B are coprimes, then their HCF is said to be 1. 2 numbers are said to be coprimes if they got only one factor common. If they got only one factor common, that is 1. If they have only one factor common, that is 1, then the numbers are said to be coprimes. 2 and 3, they got only one factors common. So what is the divisibility rule for 6? Divisibility rule for 6 is divisibility rule for 2 and divisibility rule for 3. 2 and 3 combination will give you 6. Suppose if it is 12. These is nothing but 1 into 12. Next it is 2 into 6. Next it is 3 into 4. These writing the number itself. 2 and 6 are not coprime. 12 divisibility rule is 3 and 4 divisibility rule. 18 divisibility rule is 2 and 9 is the divisibility rule. 35 divisibility rule is 1 into 35 and 5 and 7. The divisibility rule for 5 and 7. 33 divisibility rule is it should be divisible for 3 and 9. If you take any composite number except the square of a prime number. Why? Because if I take 9, 9 is nothing but 3 square. You cannot write it as a product of two coprimes. 3 and 3 HCF is 3. 9 writing the number itself is 1 into 9. 25 is 1 into 25 and 5 into 5. 5 and 5 HCF is 5. Write 25, writing the number itself is 1 into 25. I hope the idea is clear. In wherever the case except the square of a prime number, every other composite number can be written as product of coprimes. Here in this case, if it is square of a prime number, we will use Euler's theorem. For enrolled students, I have already discussed 40-50 questions only on Euler's theorem. I hope the idea it is clear. Composite number except the square of a prime number, write down it as a product of two coprimes and then do independently. 6 divisibility rule is 2 and 3. 12 divisibility rule is 3 and 4. 18 divisibility rule is 2 and 9. 33 divisibility rule is 3 and 11. Key point number 6, I hope it is clear. Composite number is nothing but a number which has got more than 2 factors. The number which has got only one factor is 1. The number which has got exactly 2 factors is a prime number. A number which has got greater than or equivalent to 3 factors is called a composite number. Key point number 6. Next one. Key point number 7. Key point number 7. Key point number 7. One more key point is there, then we will get into a problem solving. Divisibility rule for 5, 5 square, 5 cube, 5 power 4 and so on up to 5 power k. And so on up to 5 power k. Divisibility rule for 5, 5 square, 5 cube, 5 power 4 and so on. Now concept, see here. Suppose if it is xy is in base system 10, x is in base system 10, which is 10x plus 5. Why? xy, if xy is divisible by 5, this is divisible by 5. Y should be divisible by 5. That means y unit digit should be either 0 or 5. Unit digit should be either 0 or 5. I hope the idea it is clear, because for any natural number greater than 1, 5 is divisible by 5, 15 is divisible by 5, 20 is divisible by 5, 25 is divisible by 5. XYZ in base system 10, x is in hundreds place, 100x plus 10y plus z. If this is divisible by 5, 25, 100 is nothing but 4 into 25. That means 10y plus z, which is nothing but the last 2 digit number, yz. Yz is nothing but the last 2 digits. Last 2 digits should be divisible by 25. Last 2 digits should be divisible by 25. Suppose if I take a 4 digit number, sorry, if xyzw is in 4 digit number, units place, tens, hundreds, thousand, these nothing but 1000x, these 100y, and it is 10z plus w. This is divisible by 125, 125 into 8. Left hand side it is divisible by 125. These divisible by 125, 125. This should be divisible by 125. 5 we got unit digit should be divisible by 5. 25 we got last 2 digits should be divisible by 25. If it is 3 digits, last 3 digits, if it is divisible by 125, that means the number is divisible by 125. Now let us write. If it is number 5 power 1, right? So the divisibility rule for 5 is, the divisibility rule is unit digit should be divisible by 5. Unit digit should be divisible by 5. If it is 5 square, last two digits should be divisible by 25. If it is 5 cube, last three digits should be divisible by 125. If it is 5 power k, last k digits should be divisible by 5 power k. I hope the idea is clear. 5 power k and 2 power k, principally the divisibility rule remains the same. If it is 2 power 4, last 4 digits should be divisible by 4. If it is 5 power k, last k digits should be divisible by 5 power k. Last k digits should be divisible by 5 power k. I hope the idea it is clear. Last key point number 8. The divisibility rule for k plus 1 in base system k. Divisibility rule for k plus 1 in base system k. Divisibility rule for k plus 1 in base system k. Listen carefully, sir. What is the divisibility rule for k plus 1 in base system k? Suppose if I take the same 3-digit number xyz in base system 10, these units tens hundreds, 100x plus 10y plus z, these nothing but 99x plus 11y plus x minus y plus z, right? Now see here, if xyz in base system 5, these nothing but 5 power 0, 5 power 1, 5 square, 25x plus 5y plus z, these nothing but 24x plus 6y plus x minus y plus z, Now see here, if you observe closely, this is in base system 10, in base system 11, the divisibility rule is sum of the odd places minus sum of the even places. In a base system 5, the divisibility rule for 6 is sum of the odd places minus sum of the even places. That means sum of the odd places minus sum of the even places. Sum of the odd places minus sum of the even places should be divisible by k minus 1 for a base system k, for k plus 1. What is the divisibility rule for k plus 1? Sum of the odd places minus sum of the even places should be divisible by k plus 1. I hope the idea it is clear. Divisibility rule for k plus 1. Suppose if we ask in a base system 7, what is the divisibility rule for 8? It is nothing but sum of the odd places minus sum of the even places. In a base system 9, what is the divisibility rule for 10? Sum of the odd places minus sum of the even places. Extremely important key point. Whatever we are doing for a base system 10 also works for any other base system.